What is the energy of a photon of ultraviolet radiation with a wavelength of 250 nanometers? A. 5.0 electron volts, B. 2.5 electron volts, or C. 4.0 times 10 to the negative 2 electron volts. The energy of a photon is directly proportional to the frequency. Specifically, it is equal to Planck's constant h times the frequency nu. The value of Planck's constant is 6.63 times 10 to the negative 34 joule second. We're not given the frequency in the question, but we are given the wavelength, which we can use to calculate the frequency. The frequency of an electromagnetic wave is equal to the speed of the wave, c, divided by the wavelength, lambda. The speed of an electromagnetic wave is 3.00 times 10 to the 8th meters per second, and we're given a wavelength of 250 nanometers. For unit consistency, the wavelength we plug into our formula must be in meters. So we change 250 nanometers to 250 times 10 to the negative 9 meters, since a nanometer is equivalent to 10 to the negative 9 meter. When we do the calculation, meters cancel out. Punching these numbers into a calculator, we find that the frequency is 1.20 times 10 to the 15 cycles per second. We can now calculate the energy of the photon, which is equal to Planck's constant, 6.63 times 10 to the negative 34 joule second, times the frequency, which we just calculated to be 1.20 times 10 to the 15 per second. Second and per second cancel out, and we get an answer of 7.96 times 10 to the negative 19 joules. Photon energies tend to be small numbers like this. It is more convenient to express it in a smaller unit. The most commonly used unit is electron volts. 1 electron volt is equivalent to 1.60 times 10 to the negative 19 joules. An electron volt is the energy gained by an electron when it is accelerated through a potential difference of 1 volt. This energy is equal to the charge of the electron, 1.60 times 10 to the negative 19 coulombs, times the potential difference of 1 volt, or 1.60 times 10 to the negative 19 coulomb volt. 1 coulomb volt is equal to 1 joule. To convert our answer to electron volts, we multiply it by 1 electron volt, divided by 1.60 times 10 to the negative 19 joules. This gives us an answer of 4.98 electron volts, which we round off to 5.0 electron volts. There are 2 significant digits in 250 nanometers, so we only keep 2 significant digits in our final answer. Note that we kept an extra digit in the intermediate results. This is so that we do not build up round-off errors. The correct answer is A.